This is a review for the different methods that we've covered on how to solve systems of equations. These are not all the methods, but these are the ones that we've covered so far. So, if you have a graph, that's important, and slope-intercept form, with b equaling whole numbers, then you can use graphing. So this is y equals mx plus b, where b is a whole number. If you have one term with the same or multiple of the coefficient, then you can use elimination. So that's like negative 2x and 2x, or negative 3x and 6x for the multiple. Finally, if you have one variable that's isolated or almost isolated, like x equals 2y minus 9 or 2x plus y equals 11. Those are some examples of that. Then you can use substitution. So we're going to go through and do one problem of each, just so that you can see how each method works again and recall why it's best. So when you have a graph, which we have here, and the equations are in slope-intercept form, and when I isolate my slope and my y-intercept, this is a whole number. I can graph that. Fractions make it hard, so we want to have whole numbers to make it easier. So when I graph that line, 0, negative 2, and we go up 5, right 4, 1, 2, 3, 4, 5, 1, 2, 3, 4. And there is line 1. So then when I graph the second one and I isolate my slope as negative 1 over 2, and I identify that my y-intercept is 0, 5, again that's a whole number. So starting at 0, 5, I go down 1, right 2, down 1, right 2. And that's line 2. So it's kind of obvious. You can see where the intersection is. It's right here. So my solution is the point 1, 2, 1, 2, 3, 4, 1, 2, 3. So the solution is the point 4, 3. You have to write the solution in point form to receive full credit. So now let's look at elimination. So when I look at this, I can see that I have 3y and negative 3y. So that's the same coefficient, just with opposite signs. So when I add them up, there's no need to multiply. because they're already the same number. So when I line up the equations, x plus 3y equals 9, and 8x minus 3y equals 18. Remember that we are adding them. 1x plus 8x is 9x. 3y plus a negative 3y is 0. And 9 plus 18 is 27. So I get x equals 3. So for my solution, I have 3 comma something. So now I take this and plug it back into one of the equations. I like that one. So I'm going to say that 3 plus 3y equals 9, minus 3, minus 3, 3y equals 6, divide, and we get y is 2. The final method that we've talked about is substitution. And I'm looking for an equation that is almost has one variable isolated. So both of these have single variables, but if I use the y, then I have to get rid of the x and change the sign. So using the x is easier. So I'm just going to add y to both sides, and I get x equals y plus 6. So I'm going to use this any place that there is an x. So then we're going to go to this equation, 4 times something plus 3y equals 3. And I'm going to use y plus 6 for the x. So 4y plus 24 plus 3y equals 3. These are like terms that I have to combine before I can do anything else. That's 7y plus 24 equals 3. Subtract 24 from both sides. 7y equals negative 21. Divide by 7, and I get y is negative 3. So now that I have one variable, I'm just going to take this and plug it into my equation that I've substituted. So x equals y, which I can substitute right here, plus 6. I know that my y is negative 3, so this is 6 plus a negative 3 is 3, x is negative 3. So I know that my solution is the point 3, negative 3. So as you look at these, notice that I could have used more than one method on most of the equations, but the method that I chose was the easiest with the least amount of steps and work. And this is the review for solving systems of equations using graphing, substitution, and elimination.